In this demonstration, we're going to show you how potential energy can be converted into kinetic energy through a chemical reaction. Here's the setup. In a beaker, I have two liquids, sulfuric acid and alcohol. Now, because of their physical properties, the liquids don't exactly mix. So the sulfuric acid is mostly at the bottom of the beaker, and the alcohol is mostly at the top of the beaker. All the way at the top of the picture, you see a spatula that contains a purple compound called potassium permanganate. All right, those are our three chemicals. They all have potential energy. In a moment, we're going to mix them, and that potential energy will be converted to kinetic energy through a chemical reaction. Okay, here we go. We've mixed the potassium permanganate with the other two chemicals. Now look at what's going on at the bottom of the beaker. You see all those bubbles? That's a chemical reaction. In this particular chemical reaction, the potassium permanganate is being converted into dimanganate. Now look what happens. The dimanganate floats to the top of the beaker and starts another chemical reaction with the alcohol. This chemical reaction takes the potential energy in those two chemicals and converts it to kinetic energy. And you see that kinetic energy in the form of light, and you also hear it in the form of those popping noises you're hearing. So this chemical reaction is converting potential energy into kinetic energy. It turns out there's another form of kinetic energy being produced here as well, and here's evidence for it. You see those flames? Those flames are the result of the alcohol catching fire. Why did the alcohol catch fire? Because another form of kinetic energy being produced here is heat. And the heat gets so intense that eventually the alcohol catches on fire. Now, as the text points out, when something burns, that's a chemical reaction. So this is yet another chemical reaction that you're seeing in this demonstration. All told then, there are three chemical reactions going on here. The first one is between potassium permanganate and sulfuric acid. That reaction takes some of the potential energy in each of those chemicals and converts it to kinetic energy. You see evidence of that through the motion and the bubbling that you saw at the bottom of the beaker. The product of that chemical reaction then rises to the top of the beaker and starts a second chemical reaction with the alcohol. That chemical reaction also converts potential energy to kinetic energy, and the evidence for that are the flashes of light, the popping noises, and the heat. The heat becomes so intense that it starts a third chemical reaction, the combustion of alcohol. That chemical reaction also converts potential energy to kinetic energy, and the evidence for that is the flame, which is, of course, both heat and light.